So this is our first look at exercise 6E. It's looking at tangents and normals, which you've probably seen a bit of, but perhaps not in this detail. And notice it's tangents and normals to a circle at a given point. So this is quite a complicated section of the work that we do in year 12. So we notice it's at 6E.1. I think there'll probably be a couple more lessons on this, just on this exercise. So anyway, a little starter for us. Which of these equations represent a circle? So your job is to try to work it out. Now some will be obvious. You notice the first one should be obvious if it is or isn't a circle. But the next two, I think you're going to have to do that, complete the square twice to determine whether or not it is a circle. So I'll leave you to do the first one. Hopefully you'll suss that one. The second one is probably the hardest. It looks the hardest because it says 3x squared plus 4xy squared. But is it not a circle already then? Because all the examples we've seen, I think so far, have got the same number there and there. So I'm just thinking, already I'm thinking that's not a circle. Now, if you're wondering what it might be instead, you might find that you get these shapes. So they're like circles, but they're not. Some people call them ovals. In mathematics, we call them ellipses. So already I think that one, because it says 3x squared and 4xy, I think that one's an ellipse. This one, I did say I was going to let you do it, but probably you've already sussed that it's a circle. The 16 moves over. It's 4 and 4 in each direction. So I think this one is. I think this one probably isn't because of the different numbers. Now these have the same number, so I'm tempted to say that this is a circle because it's got the same number in each case. So for each circle it says find the coordinates in the center of its radius. Well, this one, the center, you'll notice, is at the origin because it's a dead easy one, and the radius is 4. This one I'm saying isn't one, so I'm not going to bother. This one I think I've got to do. So collect the x's together. Oh, so minus 4x y squared plus 6y. I think last time I told you that just move the 18 onto the other side, so minus 18. Do your completing the square trick. Hopefully you're good at this now. Y squared plus, y plus 3 all squared and minus 9. That's good. That's good. Equals minus 18. Obviously there's a problem here. If you think about this, is minus 4, minus 9. That actually makes minus 13, which I move it over. I still think I have a negative 5 over there. I think this equation is actually not a circle. I thought it was going to be. A good job I checked, because it turns out I think it's that. And you can't have a negative radius r squared thing. So I think, yes, that is a circle, 0.4. That's what I said. Not a circle. Oh, good. That's the posh picture as well. I'm pleased I've done that. It says not a circle, it's an ellipse. And it seems to be slightly, because I've got the 4. That's interesting, isn't it? Because I've got 4y squared, it seems to have gone longer that way. It's gone eggy in that direction. Sort of stretched it that way. I would have thought it's gone the other way, but seems to be longer in that direction. Seems to be anyway. I don't know what you think. And the last one, not a circle, because we can't find its radius. Yes, I like that. All three of those I agree with. So anyway, tangents and normals. The tangent to a circle is perpendicular. Now you should know this rule from GCSE, and you should also know this word normal. So whenever you get a curve in maths, you often ask to find the tangent at that point. So say it was that point there. You draw the tangent just clips the curve and just touches it and goes the same way as it at that point. Now if that's the tangent, this is the normal. You'll notice there's another word for this. This is sometimes called perpendicular. So the perpendicular is at right angles to the tangent, and the word we use for that perpendicular is normal. So you get tangents and you get normals. It's important that you know the difference. Now for a circle, we have, there's my circle, beautifully drawn, there's my radius, there's my tangent, and effectively then, notice this radius is the one that is normal, or perpendicular, to the tangent. So underneath this it says, when we find equations and normals of curves, we use differentiation. Now you may or may not have seen differentiation yet, but we're not doing curves, and we're doing circles. So when we are doing these, there's a little trick that we can use which doesn't need differentiation. So here we can quite easily find the radius, and we will probably be able to quite easily find the gradient of this radius. And because we know the gradient of this, it's quite easy to find the gradient of this. So there's a way round you do it, and it's important that you suss the difference as well. Later on we'll start with the tangent and we'll get its gradient, and then we'll be able to do the same thing for the normal using a little trick. But on this time, we don't get the tangent first, we get the radius first, we get the gradient of the radius first, and then we can find the gradient of the tangent. So here's a question to try to show what's going on in these questions. So I've drawn for you I think I've lost my pen. Let's go back, get my pen. So I've drawn for you a circle, and you can see it's got a centre 2, 3. So that's why I've said to you it's got an equation of x minus 2 all squared plus y minus 3 all squared, and I obviously think it's got a radius of some description. I don't know what the radius is actually, it doesn't tell me what the radius is. Oh yes, it does. Because it says 25, I obviously think the radius is equal to 5, because r squared is 25. So therefore my r is 5. So I've got this information about my circle already. I've got certain information. And it wants me to find the equation of the tangent and the equation of the normal at the point 5, 7. Now you should recall that the equation of a tangent or normal is governed by this line. This is what you've learnt already in coordinate geometry. Y minus y1 is equal to mx minus x1. So that equation is something we're going to use lots on this topic, because we are after the equation of a line, and a straight line is always governed by this equation. You should already know that really it's y equals mx plus c in disguise, but this is the easier version to use, so that's the version I would recommend very strongly you try to use. So I suppose if I'm going to use this, I need to know my gradients. So let's just draw a little line across, a little line down, and how far does it go across? It starts at 2, goes across to 5. This point is 5, 7 it says. So that must go 3 across. And it starts at 3 and it goes up to 7. I reckon it goes 4 up. My picture doesn't look very accurate because it doesn't look like that's a 4 and that's a 3. But that's the right idea. And my radius is 5. And that's actually seems right because it's a 3, 4, 5 triangle. It's a Pythagorean triple that you should have seen elsewhere. So anyway, so I now know my radius is 5. That's 4, that's 3. So just if I can find my gradient, a gradient of my radius, m rad, well, it's up divided by across, it's 4/3. So that was easy enough. Now that's my gradient of that line. And what's my gradient of my tangent? Now you should know that you can just, to get the gradient of the tangent, it's the negative reciprocal, because these two things are at right angles to each other. So the gradient of the tangent, flip it upside down and make it a negative, so it's minus 3/4. Now from this point on it's relatively easy to find the equation, so which one should we do first? The first one is the tangent, so it says the tangent in the question, so I'm going to do the tangent. And to find the tangent, I'm going to write y minus y1 equals mx minus x1. So I need my point on the line. My point on the line is 5, 7, so this becomes my x1, y1. So I'm going to write y minus my y1 is 7 equals my m, and notice it's the tangent, so it's minus 3/4. And we times that by, of course, the x minus, and what was the x value? It was 5. Okay, let's do that. I'm going to do it over here, otherwise I'll run out of room. So now the trick is to move that 4 over and multiply it by both things. So I get 4y minus 28, and then do the same thing but on the top over here, equals minus 3x plus 15. And I reckon the 3x move over there, probably best way to write it, 3x plus the 4y, move the 28 that way at the same time, I reckon equals 43. So that's one equation, that's the equation of the tangent, but I also want the normal. And just remember what I said, the normal is really the radius in this situation. So Now I want the equation of the normal. I use this, the gradient of the radius. So again, I use y minus y1 equals x minus x1. And it's y minus... Now, I've got a choice of points here, actually, because there's 2 points on the radius. You could use 2, 3. I'm just going to use 5, 7. So y minus the 7 equals the m. What's the m again? Oh, it's 4/3 times by x minus the 5 again. So that's times both of these. So that's 3y minus 21 equals times both of these 4x minus 20. Now I really want the x's positive. It's much prettier. So I'm going to move the 3y this way. And that will be equal, move that, I think, minus 1. So I'm sure I would write it the other way around. Minus 4x. Oh, I just left it like that. I think it's better with it like that. But it's the same thing. So 4x minus 3y is 1 minus 1, that's right. 3x plus 4y is 43, that's right as well. Another example, I suspect it's very similar. Let's have a look. Find the equation of the tangent at normal again in the diagram when y equals minus 4. So we've got a y coordinate there of minus 4 on the circle. Okay then, so very first thing I want to do is I need to find, I think, if I want the equation of the tangent at normal, I need to know this gradient. So when y equals 4, I suppose I don't know the x coordinate there. So when y is minus 4, I chuck it there into this equation. X, I don't know the x, that's what I'm trying to find. Equals 169, it says. So that's like x minus 4 all squared plus, now this is really minus 5, which I'm going to square, which is 25. So when I move it over, I can write equals, it's 169 minus 25, that sounds like 144. So therefore I can square root, it says squared, x minus 4 equals, well technically it's plus or minus 12. But I think the minus 12 will give me this point over here, so I'm going to pretend it's the 12. And therefore x is 16 when I move it over. So now I know this point is 16 comma minus 4. I've now got my point of the line. I need to find my gradient of my radius again. My gradient of my radius, it goes 12 across and it goes 5 down. Ah, interesting, that gives me root 13. Oh, sorry, 13 as my radius. So that works as well. Yes, everything's good. So my gradient, and it's going down from my radius, it's minus 5 over the 12, up divided by across, in this case minus 5 over 12. And that's for my radius. And for my tangent, which I also want to remember, m is, well, turn it upside down and change the sign, 12/5. Okay, so let's do the tangent first, same as last time. Y minus point on the line. Point on the line is minus and minus 4 equals m. What was my m for the tangent? Is 12/5. X minus the point on the line is 16. Multiply it out. 5y plus 20. Notice multiply both of them. Multiply both of them. We get 12x. 160. I think that's minus 192. So I end up then with 12x minus 5y. I might as well move that over the other side. I think that's 212, but we'll soon find out in a bit. The normal, we do the same trick. It's really the radius. So it's y plus 4 equals minus 5/12. Notice the different gradient this time. X minus 16. Times them both, 12y plus 48 was minus 5x plus 80. So I reckon probably best to move the 5x over. 5x plus the 12y. 48 moves over, and I reckon that's equal to 32. What do my answers say? I think I've even got them right. But we're going to have a look at exercise 6E. So it's only our first look at this, and I've cherry-picked some questions I want you to look at in class. So see how you get on those. Good luck.